So welcome on this lecture, and in this lecture we will describe the questions of general organic chemistry. Okay, and basically question is arises from the GOC, general organic chemistry, and in this lecture we will discuss the what is the electrophile and what is the nucleophile, what is the carbocation, what is the stability of carbocation. Okay, so several types of question we will cover in this lecture. Okay, so first of all you can see the first question, and it is very important question for BSc holders which are in the BSc first year. Okay, so question are basics, and it will be very beneficial for the IIT and NEET exams also. So first of all you can see the question says choose the following nucleophile and electrophile. So all of you know that electrophile is electron deficient. Okay, so electron deficient means, if you see here, this is the base because this containing ammonia. Okay, and the second one is the AlCl3, it is the electrophile. Okay, it is the base, it containing the lone pair. Okay, BF3, this is the acid. Okay, Cn minus, the minus shows that it is the negative nucleophile. Okay, and this is the neutral nucleophile. SO3, okay, this is the electrophile. Al3 electrophile. Phosphine PS3, okay, like that. HNO3, it is a strong acid. Okay, R3N, it is that amine, it is the nucleophile. BF3, I think it is become repeated. Ammonia, it is the base. ROH, it is the repetition occur, it is the base. SnCl4, it is the acid. Okay, so these are the some base and acids. Okay, so if you see here, first of all you can see here electrophiles. Okay, what is the electrophiles? So AlCl3 electrophile, this is the neutral electrophile actually. Okay, AlCl3 HNO3. Okay, so I will cut down the electrophile. So AlCl3 means this is the AlCl3 HNO3. Okay, and again if you see BF3, okay, BF3 is the neutral electrophile, means it is the electron deficient species. SnCl4, it is also electrophile. Okay, the next one is, if you see ROC, and you can see hydronium, this is also electrophile. And SO3, it is the sulfonium ion. Okay, so it is also electrophile. And if you see the nucleophile containing lone pair and maybe containing the negative charge. Okay, so NS3, it is the nucleophile. ROH, it is the nucleophile, and the Cn minus, it is the nucleophile. PH3 phosphine, okay, PH3, it is the what, nucleophile. Okay, and if you see R3N, it is the nucleophile. ROH, it is the nucleophile. Okay, so these are the electron deficient species, maybe either positively charged or neutral electrophile, while nucleophile is the either containing lone pair or negatively charged species. Okay, so it is the basic concept. Okay, and if compound containing lone pair, then you understood that it is the nucleophile. Okay, nitrogen also containing lone pair. How it is containing lone pair? So if you draw the structure NS3, then each atom has 8 electron. So 2 to 4, one bond single bond form 2 electron. Okay, so 2 to 4 to 6, and one lone pair 8 electrons. So only one lone pair is there, so that's why it containing, it is the nucleophile. In case of ROS, this is the, so 2 to 4 to 6 to 8, oxygen having 8 electron, 2 to 4 to 6 to 8, two lone pair of electron, so that's why it is the nucleophile. So stability of carbocation, if you see, okay, so it is the basic context behind the electrophile. Electrophile is the containing 6 electron in their octet. Okay, so that's why each atom having 8 electrons, so it is a 2 electron deficient species, and majorly attacked by the nucleophile. Okay, nucleophile is the containing either lone pair or negatively charged charge. Okay, so that's why it is the nucleophile. So it is a basic question, and it is very important question for BSc first year students, and majorly organic chemistry. Okay, because we are focusing only organic chemistry. Next one is the stability of carbocation. So if you see the stability of carbocation, so the order of stability is 3, 2, 1. all of you know, I think. If don't know about that, then you can see tertiary is more stable. This is the tertiary, this is the secondary, this is the secondary, this is the primary. So if you see, this is the having 6 electron, their octet it also in 6 electron, but it is fulfilled by 3 methyl groups, means these methyl groups are electron donating, so it gives the electron to the electron deficient carbon, so that's why stability will be arises. Okay, so there is 3 methyl groups which gives the electron to the carbon, so that's why it is more stable than this one, then this one. Okay, so that's why if you see the structure, this is the primary carbocation, this is the tertiary carbocation, this is the secondary carbocation. Okay, because this carbon is attached from carbon with 2 carbon is attached from the carbocation, so that's why it is the secondary. Okay, so if you see this, so basic concept is that if you because these moiety is same in all the carbocations. Okay, so you replace this one, and if you see the basic concept, tertiary, secondary and primary. So stability order, this is the tertiary, so it is more stable as compared to secondary, as compared to primary. Okay, so it is the basic concept. Next one is the stability order of carbocation. So it is the common question, this is the tertiary, this is the secondary, this is the. Okay, so methyl group showing the plus I effect, plus inductive effect, means it will gives electron to the carbon carbocation, and the electron deficiency will be removed out because it gives the electron. In case of this one, the plus I effect is more as compared to secondary, and less than and it is very less. Okay, so in case of secondary, 2-methyl gives the electron to this carbocation, so that's why the order of 3 to 1. The another is that it also containing 3 alpha hydrogen, it containing 9 alpha hydrogen on the basis of hyperconjugation, 3 3 6. So compound containing more alpha hydrogen, it will be more stable as compared to less. Okay, so on the basis of hyperconjugation, you can means resonance structure will be much more in this 9 alpha, contain 9 alpha hydrogen, then 6, then this one. Okay, so on the basis of this concept, you can also guess the answer. The next one is that explain the stability of carbocation. So stability of carbocation means it is attached by the 3 phenyl group. Okay, so this is more stable as compared to this one. Okay, and this, so order will be the 3 to 1. So you can okay, so stability order of carbocation will be like that. The next one is this one. The question says what is your product. Okay, so CS2COET in type, actually in organic reactions, you focuses on the concept. First of all, you will be you concentrately see that what is your substrate. So substrate is this one. What is the reagent? So NaOMe is added as a reagent, then C2S5 iodide is added. Okay, so it is the second, it is the, so first on the basis of this is the base actually, and it will abstract hydrogen from this and create the nucleophile here. After that C2S5 will become C2S5, I will be react from this one, and this charge will attack on this iodine will be removed out. Okay, so that's why your product will be C2S5 and CO, it will be released out, and ester. Okay, this is the ester, and if you see this type of reaction, then what happened here is always, if you see, ester will be converted to, if this will attack, then what happened here, alcohol will be formed. Okay, actually in this step the reaction shows hydrolysis in the presence of this one, so it is converted to COH, acid, because ester is converted to acid in presence of hydrolysis. Okay, so first of all it will attack. Okay, and it will add from this one, and after that hydrolysis means H plus will be added. So that's why hydrolysis will be occur and your product will be this one. And this is the, if you give nomenclature of this compound 1 2 3 4, so it is the 3 propanoic acid. It is the 4 carbon, so it is butanoic acid. Okay. The next question says that stability of benzyl carbocation. This is the benzyl carbocation, and this is the phenyl ethyl carbocation. Okay, so the question says that which is more stable. Okay, so all of you know that benzyl carbocation is resonance stabilized. Okay, means their resonance stabilized structure will be resonance stabilized structure can be generate. Okay, can be generate, which shows the stability, means much more resonance structure is directly proportional to stability. So that's why benzyl carbocation is more stable as compared to this one, because in this the electron, this carbocation not participated in the resonance because it is extended, one carbon extended. So that's why this carbocation will be unstable. Okay, so it is the basic reason. Okay, so these all type of questions is very important for BSc Organic Chemistry students. Okay, and if your एनी इशूज़ मीन्स अगर कोई भी क्वेश्चन आपको समझ में नहीं आया है, मीन्स नॉट अंडरस्टैंड फुल्ली, then please write down your comment in the comment box. And if you have any questions, then call me on 9555 010 629. Okay, and give your means it is my WhatsApp number, give your problems in this number, I will solve it. Okay, so thank you for that watching this video. And if you like this video, please, if you are new on this channel, then please subscribe this one. Okay, so thank you.